This video clip is going to focus on the A climates, the tropical humid climates. Just to review, we know that our A climates, tropical and humid, tend to be near the equator. Those first letters of the climate classification system generally relates a bit to latitude, with the A climates being near the equator, the B often, but not always, being near 30 degrees north and south, and then the C and D climates being in the mid-latitudes, 30 to 60 degrees or so, and then the polar climates being more poleward. The second letter of our climate system had to do with precipitation. And we can see that the A climates are actually divided up based on precipitation. Year-round precipitation in the tropical wet, monsoon patterns of precipitation in the tropical monsoon, and then in the tropical savanna, we see that there's a winter dry season. So the second letter deals with precipitation patterns. A climates don't have a third letter. We'll remember that the third letter deals with summer temperatures. And since A climates are all pretty warm year-round, they don't bother with a third letter. So our A climates are tropical. You can see they're not all perched right on the equator, but they're, in general, in the tropics. Before we get too much further, though, let's go step back a bit and note our purpose. As we study each of the climate types, we want to be able to answer the following questions. Where are the major climate types and subtypes located? What are the characteristics of each type and subtype? And then why are these characteristics found in these locations? Essentially, we're asking, why are these climate types and subtypes in these particular locations? So for each of the climate types that we go through, you should be able to figure out where we find them, what the characteristics are, and why they're located where they are. Alrighty, let's get started. We've already mentioned that this video clip will be on the topic of A climates, tropical humid climates. We know that in general they're all found in tropical locations, and then also they're further divided based on the seasonality of the rainfall. We have tropical wet, tropical savanna that has a winter dry season, and tropical monsoon that has really intense summer rainfall. Take a moment to study their distribution and see if you can come up with any generalizations on your own. All right, we're going to answer those three questions roughly on just the basic A climates here, not the subtypes. So first of all, where are they located? Well, most are located between 0 and 20 degrees north and south latitude. There's a few instances where a tropical climate can get up around 25 degrees north or south, but mostly between 0 and 20 degrees north and south. In terms of characteristics, well, these climates are basically winterless. They're warm year-round. Their average temperatures are generally above 64 degrees Fahrenheit, or 18 degrees C. Because of their high sun angles most of the year and their fairly consistent day lengths most of the year, which we learned about in Chapter 1, that leads to high year-long temperatures. They don't have a winter. Next, another characteristic is that there's lots of moisture present. Lots of warm, moisture-filled air is present near the equator, and that low pressure zone near the equator, the ITCZ, results in uplift. Both convective and convergent uplift create clouds and significant amounts of rain. All right, so we've discussed both their location, their characteristics, and why they have the characteristics that they do. Next, we'll get into the subtypes that are again divided based on their precipitation patterns. First, the AF climates, the tropical wet climates. These are warm and wet year-round. These are found closest to the equator. They get pretty much uniform insolation year-round because their sun angles and day lengths don't change much. Indeed, these are the true seasonless climates. Not only do they not have much of a winter, but they don't have much seasonality at all. They basically get the same weather day after day. If you like variety, perhaps living here is not for you. In fact, the daily temperature range from day to night exceeds the average annual temperature range from what would be summer to winter, but they don't really have seasons. So I guess, in a way, winter is nighttime. We've described why they're warm year-round. Now, why are they wet? Well, there's always moisture and uplift mechanisms available. There's moisture available because of the amount of evaporation that's occurring in the warm equatorial areas. And there's uplift as well due to convective uplift and also convergent uplift. Indeed, daily afternoon showers due to convective uplift are very common. 2-3 o'clock in the afternoon or so, the air is heated up enough that it starts to rise. As it rises, it cools, it can't hold the water anymore, and it dumps some showers. Pretty much near every day. Thus, these AF climates, these tropical wet climates, get abundant rainfall, usually around 60 to 100 inches of rain per year, though it can vary some. Thus, hot and wet year-round, no dry season. Thus, it can create and support dense forests. And indeed, these areas of the world are what we think of as the rainforest regions of the world. They have lots of moisture and sun and can support dense, thick forests. Check out the two AF climagraphs shown here. Climagraphs for AF climates are very distinctive. There's almost no temperature variation throughout the year, and also the temperatures are quite high. Additionally, they get a lot of rainfall, usually to 60 to 100 inches, in this case even a little bit more than 100 inches, and there's no dry season. Year-round rain. So as the AF code here describes, it's hot and wet year-round. Let's take a look at these two climagraphs and notice that one's in the northern hemisphere and one's in the southern hemisphere. Though it's very difficult to tell what hemisphere these are in because the temperature profile varies very little. Though you can kind of tell here, there's a little bit of a hump in the middle here, indicating this is probably the northern hemisphere, and a little depression in the center months here, indicating it's probably a southern hemisphere. Though it's truly difficult to tell. Next, let's consider AM climates. And the M in this case, of course, stands for monsoon. So these are our tropical monsoon climates. We find these climates in areas we expect to experience monsoons, which are those seasonal reversals of the trade winds due to the heating of the interiors of large continents. We said that South Asia, Southeast Asia, and Western Africa were great examples of that, as the center of the continent heats up in the summertime, creating a regional low pressure where generally there's a high pressure. Generally, the high pressure fuels the trade winds, and winds go from the northeast. But when this heats up in the summertime and it creates a low pressure because of the rising air, the trade winds are reversed and a bunch of warm, wet air comes back this direction, creating the monsoons. Similarly, the same process happens in Africa. For characteristics, well, they get extremely heavy rainfall in the summer during the monsoon. Thus, the second letter refers to the monsoon, M. They get this off-the-charts amounts of rainfall just during 2 to 4 months in the summertime. And because of this intense rain, the annual precipitation averages are outrageous, generally between 100 and 200 inches per year, and sometimes even higher. Wow! Temperature-wise, monsoon areas tend to be warm year-round, but they actually might be slightly cooler during the summertime due to the cloud cover from the rain-producing monsoons. And they also have a slightly greater annual temperature range than our tropical wet climates, than our AF climates did, because they're not exactly on the equator. They're a little bit further poleward. Let's check out some climagraphs. Notice the year-round high temperatures. Still very much an A climate. Notice also that there's a dip in temperatures in the summer months, which sometimes it makes it difficult even to determine that it's in the northern or southern hemisphere. The dip during the summer for the temperature is a result of cloud cover. Also notice the literally off-the-charts rainfall that is experienced 2 to 4 months during the year. And check out the total rainfall. 118 inches here and a whopping 203 inches in this station. So you should recognize a tropical monsoon climograph by the fairly high year-round temperatures that may dip during the summer months, and also, most importantly, the huge amount of rainfall during the summer months. May be difficult to tell which hemisphere it's in. This one's clearly the northern hemisphere as it's cooler. On these outer 6 months, this one's much more difficult to tell, likely because it's closer to the equator. Next, for the A climates, let's check out AWs, which are called tropical savannas. The A again stands for that tropical humid condition, and W, remember, this is for precipitation, means a winter dry season. Things to notice about tropical savanna climates, the light green on this diagram. First is that they are the most extensive of the A climates, and also that they extend up to almost 25 degrees north and south. Their distribution essentially matches the fluctuation that you see seasonally in the intertropical convergence zone. Basically, they're in the ITCZ in their summer months, so low pressure, rising air, and rain, but they're under the influence a bit of the subtropical high in their winter months. So you have higher pressure, descending air, and not much rain. Thus, they have a winter dry season. Overall, AW climates also get less rainfall than the other A climates because they're not as associated with that low pressure system right at the equator. And they also don't have enough year-round moisture to support dense rainforest. Instead, you have savannas, which are tropical grasslands, that dominate, complete with zebras, giraffes, and elephants, etc., at least in Africa. Let's check out the climograph. Again, notice the relatively high year-round temperature. Sometimes you'll see more of a temperature variation in AW climates than you would in AF or AM climates. Also note the seasonality of the rainfall. There's a definite dry season in the wintertime. This is a northern hemisphere. This is in the southern hemisphere. So here the dry season is in the southern hemisphere wintertime, May through September. So that distinct dry season again results in this region being a grassland. It cannot support dense forests. And think about that winter dry season, what's going to happen to these grasses. They're very prone to fire in the winter season. All right, we've worked our way through the 3 A climates: tropical wet, tropical monsoon, and tropical savanna. You should be able to answer those 3 questions regarding where each of these climate types exists, the characteristics of each, and why they have the characteristics that they do. Table 8.2 in your textbook offers a great summary of the A climates, and you should also pause the video and make sure that you can answer these questions on the A climates. If there's something you don't quite understand or aren't able to explain fully, you'll want to pause the video again and go back and find the answers.